Hi dear students, welcome back to my session. Today also we will discuss a few problems on the star and delta transformations, and also if we time permits we will discuss nodal analysis problems. But firstly we will discuss transformation techniques. After that we will discuss nodal analysis techniques. Actually, yeah, we have done only few problems on the nodal analysis. That is the reason I took the topic in again for the solving of few problems on the nodal. We have solved so many problems on the mesh analysis, but we missed it for the nodal analysis. So let us finish that nodal analysis also by solving the two to three problems. Okay, let's start today's session. Here, first let me solve this conversions, means star to delta, delta to star transformations. First, let's read the problem. Find the value of input resistance R input of the circuit. So he wants to know the R input across this. Let me add my tools. For this, let me add my marker. So this is let me say this is a point, this is a B point. Across these 2 points, you need to be find the R input. For this is the values all the resistors which are in a different shape. They are connected. Now find the value of input resistance across R input. For this, what are the ways for the reduction of this network? Either you can apply series, parallel, or star to delta, delta to star techniques. So which comes those techniques, which techniques are suitable for this circuit? So let's analyze. So is there any possible for applying of series and parallel? Is there any possible for applying series and parallel for this? Is this two resistors connected in series? No. Connected in parallel? No. Or this, what about this? Not series, not parallel. What about this? Not series, not parallel. What about this? Not series, not parallel. So enter this network in the triangle mode across ABC are neither series nor parallel. Hence, only one method we can apply for this is star to delta or delta to star transformations. Before that, let me take the snapshot of this technique. Let me take the snapshot of this. One moment. Let me take the snapshot. Let me paste in Paint. Right. So this is circuit. Now we are looking for the circuit. Right. Now for the finding, let me add this branch. Now for the finding of this, let me add this. Now add this small marker. No, this is not good. This is better. but this the size is better. Right, this size is better. Now this is point of A, B. This is A point, and this is a B point. Your job need to be find across resistance between A and B, right? So how much value of resistance between A and B? For that, you need to apply series parallel or star delta delta star. Already we finished. We concluded that series parallel is not possible for this circuit. Then we can apply star to delta or delta to star. Where is the star? Where is the delta? Now let me find. Here any star. This is not delta. This is not delta. This is not. Only three resistors should be present for the star, or three resistors should be present for the making arrangement of delta. Now the arrangement here. This is a star, right? This is star. Entire this network is comes under this star. Means I can name it as a this is ABC, right? D E F. This D E F B A B C D. This D E F is star. Now my job need to be convert this star to delta. How I am going to be converting is important here. So now let me add the circuit. So this is one resistor. This is one more resistor. This is one more resistor. This is 26, right? 26. All the series all the all the resistors which are connected in the star are 26 ohms common resistors. Now you need to be convert that star to delta. What is the formula for star to delta? For the conversion star to delta, if this is RA, then for the converting for this two, you need to be do. So here for the finding of RAB or RDE, you should represent this two resistance. RD is nothing but a RD plus RE plus RD RE by RF. So in this way we can find this means 26 plus 26, 26 plus 26 plus 26 into 26, 26 divided by 26 plus 78. So the value is 78. Same values will be present here 78, 78, 78. So 78 because all the resistors are common. 78, 78, 78 means for the conversion of star to delta, as you know, for the conversion of star to delta, if resistances are equal, already we concluded that already we make a note in the our previous sessions for the conversion of star to delta, for the making of delta conversion, if resistance are common, then the resistance value are r of star. Already you know this formula. R delta is equals to 3 times of R star. If R star is equals to 26 ohms, R delta will be 78, means 3 times, right? 3 times of star. So already we make a note of this. R delta is equals to 3 R star. Since when the resistances are equal, R is equals to R, right? Hope you clear. So by this analysis you make that this is 78, right? Hope you clear. Now what I am doing is, let me erase this. Here is this. So by removing this, you can add one more one. Let me changing like this. So by changing this value of this, so this is the value. Let me redraw the circuit clearly, then we can understand. So when I am finding this, let me add this resistor. Right. After converting the middle of star into the delta, let me compare with our circuit with this circuit. This is circuit already given in the problem itself. Just we converted this middle part into the delta. Now let's see. Right. From this, we can apply. This is delta. This is one more. This is delta. This is delta. Now we can convert these three deltas into the star, like this. Change my color. Star. Here one more star. Here one more star. Sorry. Let me remove this disturbance. The value will be this 78. Let me rewrite that value. This value is 78. Right. Let me convert this 3 delta to star. So for the making of conversion from delta to star, as you know, what's the formula? Delta to star conversion. RA, if this is RA is equals 30 into 36 by summation of these three values of resistors. So let me do that one by one. First, this means 30 plus 36 plus 30 into 36 by 78, right? 30 into 36 by 78 plus 30 plus 36. Hence it will be 79.84. The value is 79.84. This value. Next, what about this? Let me find this also. For the finding of this, we need to be depend upon these two adjacent terms. 30 plus 78 plus 30 into 78. What I am doing, so this is wrong, right? I am doing for star to delta delta. So let me remove this. This is wrong. Let me write star to delta. Making of star to delta, multiply, add in summation, right? For that, 30 into 36 by, so this is a formula for star to delta. 30 into 36 by total addition of this 30 plus 36 plus 78. So means 30 plus 36 plus 78. 30 into 36 divided by 144. Hence that will be 77.14. Right? So this is about this. What about this? This is 30 into 78 by 144. Then it will be the answer will be 16.25. Value will be 16.25. 16.25. What about this? This will be 36 into 78. 36 into 78 by 144 into 78 divided by 144. Then your answer will be 19.5. Now you got the star of this connection. Let me write this star by removing this. So I'm going to be writing 77. This is 77.4. 77.4. Wait. This is 77.4. And this 77.4. This is 16.25. This is 19.5. Let me remove the rest of the elements. Let me remove. So this I can remove this. Let me remove this. Let me remove this. Let me remove this. Let me remove this. So this is 19.5, 16.25. We will write again. Right. This is 77.4. This is 16.25. Now this is 19.5. So I'm done with this. Let me move to this circuit. This is the connection. Sorry. This is the connection. We got it. So A, D, E. We're done. So this is the middle point. Next. Again delta to star. Let me do this. 12 into, let me add first 12 plus 78 plus 6, it will be 96. Let me write here 96. For the finding of this, you need to be multiplied 12 multiplied by 78 by 96. Then you will get value 9.75. The value will be 9.75. Next, 12 into 6 by 96. The value will be 0.75. 0.75. What about this 78 into 6 into 6 divided by 96? The value will be 4.875. This will be 4.875. Let me remove the rest of the part. Let me remove these parts. Then we can. So right. 9.76, 0.75, 4.875. The value will be 4.875. So this is a resistor. 3 resistors across this element. What about this? Let me solve this also. This 0.6 ohms are. What about this? 0.6, right? That is 0.6 itself. This is 0.6 only. Let me find this. Let me add this. Right, 78 plus 15. 78 plus 15 plus 0.6. It will be 93.6. 93.6. Now let me do for the converting delta to star. 78 into 15. 78 into 15 divided by 93.6. Then it will be 12.5. This value will be 12.5. Let me write again. 12.5 for this star. Next, what about that? 15 into 0.6 divided by 93.6, 3.6. The value will be 0.0961. 0.0961. 78 into 0.6 divided by 93.6. The value will be 0.5. So now remove this, then image this value. Now let me remove this. By removing this, I'm adding, right? I'm adding this. Right. This is 12.5. This is 0.0961. What about this? This is 0.5. So this is 0.5. This is 12.6, right? Now let me do some little bit calculations by removing this. Before that, let me see this first our circuit. Right, this is our circuit. From this circuit, we converted in this form. All deltas from middle, just we converted this star to delta. Again, we converted this star, this delta to star, this delta to star. Again here this delta to star. Again this delta to star. Now my circuit is look like this. So here this is my yellow indication of is indicates my final circuit. Sorry, after the applying the transformation techniques, my circuit is look like this. Here they all are is in star connection as of now. Now for that, if you observe this diagram carefully, here which are in series, which are in parallel, let me find it out here. Here this 19.5 and 9.75 are in series, and what about 16.25 and 12.5 are in series. Let me add this, then we will think further. So let me add this 19.5 plus 19.5 plus, that is 19.5 only, right? 19.5 plus 9.75. 9.75. Then the value will be 29.25. Let me remove this, and by adding 29.25. The resistor is here 29 point, sorry, 29.25. Don't make any point, don't add any point here, because you remove that point by adding this all these two resistors. 29.25. Then what about this 16.25 and 12.5? 16.25 plus 12.5, then it will be 28.75. It will be 28.75. Let me remove that also. It will be 28.75. 28.75. Let me remove this unnecessary part. So now this is 27.4. Remove this 27.4. Adding this. Right. Now, is there any other way of solving these types of circuits? So this is, so by observing this circuit, you should understand here these are the resistors 77.4, 29.25, 28.75 and 0.75 for 4.875, 0.5. All are connected in the some connected manner. So there are some every two sides of the resistors are connected in a complete loop. But here the only one resistor which are not connected to the secondary terminal are not connected. So hence we can eliminate this resistor. Why? Because the current will not flow through this resistor. So hence I'm going to be removing of this resistor. Right. So here after removing of this resistors, this complete circuit is, sorry, after removing of the resistor, this complete circuit 28.75. Let me add this 28.75. This 28.75 and 0.5 will be in series, right? Then 28 point. Let me add the 28.75 plus 0.5 will be 29.25. By adding these two resistors, then the value will be 29.25. Let me add that by removing this circuit. I'm going to be removing this circuit. Then that will be 29.25. It will be 29.25. This will be 29.25. So here, hope you understand what I'm trying to say. Now you got in some reduction of your circuit. Here we observe few of the resistors like 4.875, 29.25 are there. This, let me convert this star to delta. Let's see how that will happen. If I convert it like this both are parallel, right? The resulting value will be right. Let me do that, or else shall we do this? We can't do this. The middle of the resistor is somebody is connected. Right. Let me do this. Converting of this. Is there any way if I find this? Let me do this. Let me draw the circuit in this way. Let me find, is there any way of finding the root? This is 29.9.25. If I make like this, then very clear for us. Right, right. So let me do this. It will be help you for us. Right. I'm going to be redraw the circuit 29.25, just bending from here to this. So let me remove the 29.25 by making the circuit. So this is 29.25. This is also 29.25. This is 4.875. Let me remove this F also. Here, if you observe this F, these are connected into the series, right? Right. This is 29.25. Let me write this 29.25. This 29.25 and this 4.875 are in series, right? Let me add this two. Hope you clear what I'm trying to say. Let me add this marker here, right? Now, right. Let me make you clear again. This 29.25, which is series with this, because F is only that we make that point by removing this F point. Let me remove this F point. Right. Sorry. This 29.25 and 4.875 are in series. Let me add this 29.25 plus 4.875. Then that will be 34.125. The final value of this is 34.125. Now you can eliminate this. Sorry. Now you can eliminate this by adding the complete value of resistor 34.125. Now I am adding the my resistor 34.125. Now here 34.125 and 29.25 are in parallel. Now do the parallel circuit. 34.125 into 29.25 divided by 34.125 plus 29.25. Then it will be 15.75. Then it will be 15.75. Let me add that value also. 15.75. So let me remove that circuit as well. Now I am removing the circuit. Right. By making the arrangement like this, 34.15.75. Now these three resistors means 77.4 plus 15.75 plus 0.75. These three are in series. Let me add these three resistors plus 15.75 plus 77.4 plus 0.75. Then my resistor is approximately equal to 94 ohms. The value of resistors across A and B will be 94 ohms. Let me check from this. So sometimes it's giving some different way, right? So from the screen, if you observe this, our screen, sorry, this is our diagram, right? From this diagram, we converted this 36 and 30 and this star making circuit. Let me add the circuit itself. So here we added some resistor, right? This resistor value is 78. From this 78, we converted star, right? After converting 36 into 30, 36 into 30 divided by 144. Then it will become a 9, not 77.4. Please make that value will be 9. So I'm going to be removing this. Sorry. The value will be 9. There are some mathematical errors will be there. Please try to rectify from your side. But the procedure is same. From my end, the procedure is same. You can use any delta to star or star to delta. You can use any conversion. The procedure is same. But any mathematical calculations, they may have the mathematical errors. So that is not a big mistakes. So try to figure it out, that mistake from your end. So this will be 9. So after adding, you will get some, this is value will be 9. And what about this value? 78 into 30. 78 into 30 divided by 144. Sorry, 78 into 30 divided by 144. The value will be 16.25. This value will be 16.25. And this, what about this value? 36 into 78. 36 into 78 divided by 144. That value will be 19.5. So this value will be 19.5. Then the new value will becomes here. So from here again you need to be converted from again star to delta. Then you need to be add these two elements 16.25 and this value will be removed and it means 26. 78 into 15. So it will be become 78 plus this value will be 78 as you know already. 78 plus 15 78 plus 15 plus zero point 0.6 plus 15 plus zero point 0.6. Then the value will be 93.6. You should do 26 into 15. 26 into 15 divided by 93.6. Then which this will be 4.16. 4.16. Some mistakes may be happened to 26 into 15. So not 26, 78 into 15. Sorry, 78 into 15. Let me remove that. 78 multiply with 15 divided by 93.6. Then this value will be 12.5. Sorry, that value will be 12.5. What about this 15 into 0.6? 15 into 0.6 by 93.6. Anyway, this is going to be removed. This is not going to be considered because this is uh, not flowing any current on this branch. So this is going to be eliminated. What about this 78 into 0.6? 78 into 0.6 divided by 93.6. 0.5. The value will be, this value will be 0.5. This value will be 0.5. So hence, since this is going to be eliminated, so I am going to be removing this branch. So I'm going to be erasing this branch. So then I'm going to be adding of this complete resistors, right? Again, I'm going to be erasing this also. this part is going to be erased. So hence 9 plus 16.25, sorry, not 9, 16.25 plus 12.5 plus 5. 16.25 plus 12.5 plus 0.5. Then this value will be 29.25. Already we got that same value. Sorry. So this value will be 29.25. I am going to be removing this. So 29.25. Just I am checking why my answer is getting got wrong. Just I am checking 29.5. This value will be 29.25. Then what about this? Again, make this that into star. This is 78, as you know. This is 78. This is not 26. This is 78. Right, that is 78. 78. Let me add that is 78. I'm adding 78 into 6. Whatever the value, this value is 78. 78 plus 6 plus 12. How much? 78 plus 6 plus 12. 96. 96. 78 into 6 by 96. Then this will be 4.875. The value will be, this is 4.875. 4.875. The value will be 4.87. Now you need to be add this because this connection completely series, right? So for the making of this arrangement, there is no point here. It will be common for this series. Hence 4.875 plus 29.25. 29.25. Then the answer would be 34.125. I am removing this. 34.125. 34.125. Now complete this star. 78 into 12 divided by 96. 78 into 12 divided by 96. So 96 or 93. This 12 plus 6 plus 78. 6. 12 plus 78 divided by 96. Then the answer will be 9.75. So this is 9.75. 9.75. What about this? 12 into 6. 12 into 6 divided by 96, which will be 0.75. This is 0.75. 9.75 plus 19.5. 9.75 plus 19.5, which will be 29.25. So this is 29.25. So let me remove that. This is 29.25. 29.25. Now 29.25 and 34.125 both are in parallel. 29.25. 29.25 into 34.125 divided by 29.25 plus 34.125, which will be Wait. 29.25 multiply with 34.125 divided by 29.25 plus 34.125, which will be 15.75. Correct. Whatever we are doing, all the steps are correct. There is no mistakes from our end. So maybe some calculations mistakes from the PDF end. So don't worry. So whatever your process is correct. So then after adding this 15.75 plus 9.75, you will get answer, not 94. This is wrong. So you will get, after adding these three resistors, 0.75 plus 15.75 plus 9, you will get 25.5. Total value of resistance across this 25.5 ohms. So hope we clear of this session.